Start.
Welcome to the video session. Myself, Professor Dr. P. Selvam, Professor in Electrical and Electronics Engineering, Vinayaka Missions Kripanadavari Engineering College, Salem. It is a constant college of Vinayaka Missions Research Foundation, Deep University, Salem, Tamilnadu, India. So today we are going to discuss about the topics in basic electrical engineering. So in that we are going to discuss about how to solve electrical circuits using Ohm's law and Kirchhoff's law. So as we are all very much familiar about the Ohm's law, it states that V is equal to I into R. So in Ohm's law, the V stands for voltage, the unit for voltage will be in volts, and I stands for the current in amperes, and resistance R is in ohms. So now we have to derive the equation for total resistance for three resistors connected in serial and parallel. First we will see about the serial connection. Take three resistors which are connected across the voltage like R1, R2 and R3 are connected in series across the voltage source V like this. So R1, R2 and R3. So now in series circuit the current flow is same. So I will be common for all the three resistors R1, R2 and R3. Whereas the voltage for each resistor will be differs. So this is said to be V1. And for across R2 it is V2, and across the resistor R3 is V3. So the total voltage should be equal to V is equal to V1 plus V2 plus V3. V1 is equal to I into R1. Similarly, V2 is equal to I into R2. V3 is equal to I into R3. So we have defined the values for V1, V2 and V3. Now substitute in the main equation. So it will becomes I into R1 plus I into R2 plus I into R3. So now taking the common factors I outside, then we can able to write R1 plus R2 plus R3. So now V is equal to I into R1 plus R2 plus R3. So now bringing I to the other side, so V is equal to I, V divided by I is equal to R1 plus R2 plus R3. As from the Ohm's law, R should be equal to V by I. Here R total should be equal to V by I. So that should be R1 plus R2 plus R3. Hence, the total resistance in series circuit RT should be equal to R1 plus R2 plus R3. So, here we understood that in series circuit, the total resistance should be sum of the individual resistance R1, R2 and R3. That's what we defined here. So, the total resistance for series circuit will be the sum of the individual resistance. Next we will be going to discuss about the parallel connection. So in parallel connection we can draw the circuit across the voltage like R1 is connected and R2 and R3. So here the voltage source V and R1, R2 and R3, three resistors are connected in parallel across the voltage source. Here in the parallel connection, the voltage is same for all the three resistors R1, R2 and R3. Whereas the current I will be differs. The I will be differs as I1 and I2 and I3. So the total current I should be equal to divided into I1 plus I2 plus I3. So the current I should be equal to V divided by R1. So we can write I1 should be equal to V by R1. I2 should be equal to V by R2. I3 should be equal to V by R3. So now substitute these three values in the main equation. Then I should be equal to V by R1 plus V by R2 plus V by R3. So now once again we can take the common factor V outside. Then it should be 1 by R1 plus 1 by R2 plus 1 by R3. So now we can bring the voltage common factor to the opposite side. Then it should be I by V should be equal to 1 by R1 plus 1 by R2 plus 1 by R3. From Ohm's law, I by V should be equal to 1 by R. So 1 by RT should be equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is the equation for finding out the total resistance in the parallel circuit. 1 by RT should be equal to 1 by R1 plus 1 by R2 plus 1 by R3. So suppose we are taking only two resistors R1 and R2, then this equation will be reduced to 1 by RT should be equal to 1 by R1 plus 1 by R2. So now we can take the LCM, then it should be R1 into R2, R1 plus R2. 1 by RT should be equal to R1 plus R2 by R1 into R2. So we want RT, then it should be R1 into R2 by R1 plus R2. So when the two resistors are connected in parallel, then the total resistance can be calculated using the formula of R1 into R2 by R1 plus R2. So this is what the derivation for the three resistors connected in parallel, and also we have discussed earlier in series. So now using these formulas we can solve some of the problem. So first take out this problem. Find out the total resistance between the points A and B as shown in the given circuit. So these are the points A and B. So now here see there is a combination of series resistance as well as parallel resistances shown in the diagram. So now as a first step we can take these two resistors 5 and 6 ohm. These two are connected in series. So we can add these two 5 ohm and 6 ohm. So series means by adding 5 plus 6 it reduces to single resistance of 11 ohms. So now replacing these two with this one in the main circuit. So the main circuit will be reduces to like this. So the 5 and 6, instead of 5 and 6 I am going to replace it with the 11 ohm here, and this 7 ohm will be as it is. So 11 ohm and 7 ohm, this is 3 ohm, 4 ohms and 4 ohms, 2 ohms and 1 ohm. So now again, now you take these two are in parallel now. So we can take this two parallel element and converting into single element. So it will be using this formula of R1 into R2 by R1 plus R2. So 11 into 7 divided by 11 plus 7. So 77 by 18. So by using the calculator we can do 77 by 18. 3 ohms. So 77 by 18 should be equal to 4.3 ohms. So now these two will be replaced with the 4.3 ohm resistor. So the circuit will be rearranged to a single resistance of 4.3 ohms now. So now this is 2 ohm and 3 ohms, 4 ohms and 4 ohms. So now again take these 3 resistors in parallel. First I am going to take this 4 and 4 ohm. So using the formula 4 into 4 divided by 4 plus 4. So 16 divided by 8, I am going to get 2 ohms for converting these two into a parallel of single resistance 2 ohms. So now I am going to replace it to the main circuit. So now it becomes 2 ohm and 3 ohms are in parallel. So this becomes 2 ohm and this becomes 3 ohms. So here it is 4.3 ohms. This is 2 ohms again. So now I am going to take again 3 ohm and 2 ohm this parallel combination. So converting into a single resistor. So again for 3 ohms and 2 ohms. So 3 into 2 by 3 plus 2. So it is 6 divided by 5. So it will become 1.2 ohms. So now by converting the 3 parallel resistors, it reduces to 1.2 ohms. So again rewriting our diagram. So 1 ohm and 2 ohms in series with 1.2 ohms, and this is in parallel with 4.3 ohms. So 4.3 ohms, 2 ohms, 1.2 ohms, 1 ohm. So now these two are in series. So what happens now? By adding 2 and 1, by summing these two values, 2 plus 1.2, it becomes 3.2 ohms. So it reduces to 1 ohm and then so it is 3.2 ohms and 4.3 ohms. So it is A and B. So now again converting these two in parallel, 3.2 into 4.3 ohms divided by 3.2 plus 4.3 ohms. So now adding this value, so what happens? So by using the calculator, we can calculate the value as 3.2 into 4.3 is equal to 13.76 divided by 7.5. So it gives us 1.83 ohms. So now the circuit again reduces to 1 ohm with the help of 1.83 ohms. So by adding these two, we can get 2.83 ohms. So this is our final answer. So the resistance between A and B is 2.83 ohms. So this is the answer. I hope you followed the clear steps one by one. It will be reduces to 2.83 ohms. From the diagram shown, here we are going to have the three loops are connected. So we are first naming that A, B, C, D, E, F, G, H. So now we have to find out the total resistance by looking from the battery 20 volts. Hence we have to reduce the resistance from D to E towards the battery. So first I am considering C, D, E, F, C. So this loop first I am considering. In that if you see, looking from the point C and F, all the three resistors are in series. That means 5 ohm, 6 ohm, 10 ohm are in series. That three combination will parallel with 7 ohm. Hence first I am adding the three resistors 5, 6 and 10. Then adding these three it will give 21 ohms. So now I am reducing the circuit by replacing the three resistors in a single resistor as 21 ohm. Now this 21 ohm and 7 ohm are in parallel. So now I am replacing these two parallel combination in a single resistor by using the formula 7 into 21 by 7 plus 21. So it gives rise to 5.25 ohms. So again reducing the circuit with the converted element, so 5.25 ohm. So now we are in the second, one loop will be eliminated, and the second loop now I am considering B, C, F, G, B. So this portion again, now if you look from the point P and G, so the resistor 6 and 5.25 are in series. In turn these two are in parallel with 10 ohms. So first I am adding 6 and 5.25 ohms. It will be 11.25 ohms. So now rearranging the circuit, 11.25 ohm is in parallel with 10 ohm. Using the formula I am reducing to 5.29 ohms. So these two are converted to a single resistance of 5.29 ohms. So rearranging the circuit, so I am getting 5.29 ohms, 12 ohms across the battery, 20 volts. So now these two are in series. So by adding these two, it will be reduced to 17.29 ohms. So the total resistance will be 17.29 ohms for the given circuit. So now we want to find out the total current. So total current I should be equal to V by R. So V is 20 volt and the resistance is 17.29. So we get 1.15 ampere is the current for the given circuit. So now I am going to solve the circuit as given here. For the given circuit, find out the current through each nodes, individual resistor values, supply voltage and individual power. When the given parameters are, total power is 3 kilowatts. So the power given is 3 kilowatts. So 33,000 watts. And then total current I will be equal to 12 amperes. And they are given a condition that the current flowing will be in resistor RB should be 2 times IA. And here the current is IA. And the total current I should be equal to 12 amperes. And RC, what is the condition given is 3.5 IB will be the current flow in RC resistor, 3.5 IB. These are the conditions given. So now in parallel circuit, as we are all very much familiar, the total current I should be equal to IA plus IB plus IC, the three currents. So now I should be IA plus IB, what is the condition given is 2 times IA. I am replacing it 2 times IA plus IC should be 3.5 times IB. Again IA plus 2IA plus 3.5 into IB should be equal to 2IA. I am multiplying here 2IA. So the total current should be equal to IA plus 2IA. So it will become 3IA plus 3.5 into 2IA. So it will be 3IA plus 7IA. So total it will be 10IA. So now we have to find out the total current, that is given as 12 amperes. 12 ampere is the total current I. So now IA should be equal to 12 divided by 10. So it is 1.2 amperes. IA what we got is 1.2 amperes.